Zeta potential is the scientific term for electric potential in colloidal dispersions. It is the potential difference between the dispersion medium and the stationary layers of fluid attached to the dispersed particles. Surface electrokinetic analyzer determines the zeta potential and the solid liquid interface of macroscopic surfaces based on the measurement of streaming potential and streaming current respectively. This is the surface electrokinetic analyzer that we have in our laboratory. Now I am going to demonstrate for you the operating procedures of this instrument. Here in this surface electrokinetic analyzer, we have different parts. First, we have two measuring cells. These two are two measuring cells which are connected to two different electrodes. One is pH electrode and one is conductivity electrode. These measuring cells can be mounted to this measuring cell holder. Now, for further uses, we have to connect this hollow tube to these measuring cells. The gap can be adjusted by rotating this notch in the measuring cell holder. Here we have one conductivity electrode and one pH electrode and one titration unit. This titration unit is used for the pH metric titration during the analysis. It contains 0.1 molar sodium hydroxide solution as the alkaline medium and 0.1 molar hydrochloric acid solution as the acidic medium. This is the Attract 2.1 software where we can measure the solid surface zeta potential. Before going to the measurement, we will have to calibrate the pH electrode and the conductivity electrode. So, first of all, we are going for the calibration of the pH electrode. We will select the Calib pH step. For the calibration of the pH electrode, we will have to take 3 buffer solutions of 5 pH values. One buffer solution of 4 pH, one of pH 7 and one of pH 10. Now we are going for the calibration of the pH electrode. The software will guide us through the calibration of the pH electrode. So first of all, we will have to clean the pH electrode with distilled water and keep it in the buffer solution of pH 4. Then we will click the calibration pH option in the software. Once it is done, we will again clean the pH electrode and keep it in the buffer solution of pH 7. At last, we will clean the pH electrode again and keep it in the buffer solution of pH 10. Now we will go for the calibration of the conductivity electrode. For the calibration of conductivity electrode, we will have to prepare 0.1 molar potassium chloride solution. During the calibration, we will clean the conductivity electrode with deionized water and keep it in the electrolyte solution of 0.1 molar concentration. Now we have to rinse the titration unit so that the electrolyte solution can pass through the titration units. So we will select the Rinse TU tab. Here we have two options, titration unit 1 and titration unit 2. First we will select the titration unit 1 and later the titration unit 2. We are allowing 4 ml of sodium hydroxide solution to pass through the titration unit 1. During the rinsing of the titration units, the outlet hose should be connected to a waste beaker. Before performing a first measurement, the complete electrolyte circuit must be rinsed with ultra-pure water by using an extended rinse cycle. This is the surface adjustable gap cell which can accommodate small rectangular pieces of planar samples. There are two sample holders with the adjustable gap cell. We can use double-headed tape to mount the samples on the adjustable gap cell sample holder. After mounting the samples on the sample holders, we have to insert the sample holders with the samples into the rectangular holes of the housing of the adjustable gap cell. Now we have to mount the knurled nuts with the scale on the threads of the sample holders and then mount the counter pieces of the knurled nuts and fix the counter pieces with the clamps. Now we have to compress the silicone sealing block with the knob and then tighten the knob gently. Now we can mount the surface measuring cell holder with its adapter on the dovetail guide at the surface front side. Take the surface measuring heads and insert the electrodes in the bore holes of the adjustable gap cell. Adjust the distance between the measuring head brackets of the cell holder with the knob according to the distance between the surface measuring heads mounted in the adjustable gap cell. In order to remove the air in the electrolyte hoses and the measuring cell, the system has to be filled with electrolyte solution of 1 millimolar potassium chloride solution. You can start a new measurement by clicking on the new and then standard measurement. In the solution mixer configuration, we can define the parameters of the liquids used during the measurement. The default solvent used for zeta potential analysis is water and the start volume is 500 ml. In the list of solute settings, the different solutes which shall be used for the experiment can be selected from a drop-down menu. Device setting configuration, we can define the measuring cell type from a drop-down menu. Now we can click on the green measurement button to start the experiment. After the analysis is done, the results can be exported to Excel file format. Here is a graph of zeta potential values of different membranes with respect to change in pH. The prepared membranes possess a slightly negative charge at high pH, whereas positive charge at low pH. This proves that the surface charge of the membrane is a function of pH.